Hello class, so we're going to continue the topic on gyroscopic couple. So last class we learned about um, precessional motion, angular motion and gyroscopic couple. Okay, so now precessional motion, angular motion and gyroscopic couple, we understood the concept. So let's learn about how the effect of gyroscopic couple is on an aeroplane and a ship. So we'll be learning about these two and solving some problems. Okay, so let's go ahead and learn about how the effect of gyroscopic couple is on an aeroplane. Okay, so I will show you a diagram, the top view and the front view of the aeroplane. Okay, so there are few terminologies that we need to understand and learn. Alright, so first of all, from direction of view is from the back end. Okay, so if we are viewing from the back, alright, and the back portion is called as the rear or tail end, and the front portion is known as nose or the propeller. Alright, and next you have, if so from viewing from the back, the plane can take left turn or right turn. So if I draw the axis, okay, so propeller rotates. This is the axis of spin. The propeller rotates about the nose. So it is the axis of, so this horizontal line is the axis of spin. So the vertical line with the axis of spin will become the axis of precession. We learned about precession angular motion. So this is the axis of precession. Okay, and this perpendicular axis will be the axis of active gyroscopic couple. Alright, so last class we learned about disc which is rotating, okay, and the axis of spin of a disc while the rotor is rotating, it moves. Okay, it also rotates at a particular, for a given interval of time at a specific angle. Okay, so this also depicts the same way. You have an axis of spin, you've got the propeller which is rotating, and axis of precession is perpendicular to this. Now this is the front view. So active couple is in this direction if the rotor is rotating in anti-clockwise direction, and the opposite direction will be the reactive gyroscopic couple. Okay, so this plane of spin is this one, plane of precession, and plane of the gyroscopic couple. Okay, so if omega is angular velocity of engine in radians per second, m is the mass of the engine and propeller, both the masses, propeller as well as the engine, k is the radius of gyration in meter, I mass moment of inertia, kg meter square or mk square equal to mk square, v is the linear velocity of the plane in meter per second, okay, and r, capital R is radius of curvature in meter. So omega p will be the angular velocity of precession. So omega is angular velocity of the engine. Omega p is angular velocity of the precession. So v by r. Linear velocity of the plane by the radius of curvature will give you angular velocity of precession Wp. Omega p. Okay. So there are few concepts that we need to understand here. If the plane takes right turn, okay, the effect of reactive gyroscopic couple will be, now in this scenario, nose is rotating in this direction, clockwise direction. The effect of reactive gyroscopic will be to dip the nose and raise the tail. Okay, but if you see from the rear end and proper rotates in the anti-clockwise direction, okay, and if the plane takes left turn, what will be the effect? Again, dip the nose and raise the tail. In this case, it is clockwise. It is moving in clockwise direction seen from the rear. So if it is moving in anti-clockwise direction, propeller, and you're seeing it from the rear end, and the plane takes left turn, the effect of the reactive gyroscopic couple is to dip the nose and raise the tail. If it takes right turn, effect of the gyroscopic couple is to raise the nose and dip the tail. Okay, similarly, if the propeller is is in clockwise direction and it turns left, it will raise the tail and dip the nose. Okay, and if it is going right turn, it's just the opposite. So I have just drawn a table which is easy for us to understand. Propeller, which direction the aeroplane is turned, nose of the aeroplane, tail of the aeroplane, and from where are we viewing. Okay, so both. So now here we have anti-clockwise direction, viewing from the rear end, left turn, if it takes a left turn, dip the nose, raise the tail. If it is right turn, raise, the nose gets raised, tail gets dipped. Clockwise direction, okay, left turn, dip the nose and raise the tail. Clockwise, right turn, raise is just the opposite. Okay, so this is the concept that we have. And then going forward, let's try just do a simple small problem before we end this session. So the simple problem is taken from the example 14.3. Okay, an aeroplane makes a complete half circle, 50 meters of radius towards left when flying at 200 km per hour. So the speed of, linear speed of the aeroplane is given 200 km per hour. It makes a complete half revolution, 50 meters is the radius, and it turns towards left. The rotary engine and the propeller of the plane has a mass of 400. So mass is also given. Radius of gyration is 0.3 meter. The engine rotates at, the speed of the engine is also given, 2400 rpm clockwise. So the rotor is rotating clockwise when viewed from the rear end. Find the gyroscopic couple on the aircraft and state its effect on it. So we saw in this the gyroscopic couple can be calculated with this formula. C, moment of inertia, multiply that omega and omega p. So in this formula, in this example, the radius of turn is given as 50 meters, linear velocity of the plane is given, mass is given of the engine and the propeller, radius of gyration is given, and speed of the plane is given. You can find the angular velocity of the engine, 2 pi n by 60, 2 pi, substitute the values, find, so you will get 251 radians per second. Now what is the, you need to find gyroscopic couple, I multiplied by omega p. What is I? M k square. Okay, so M k square, so you have what is M? 400 multiplied by k square, 0.3 whole square, 36 kg per meter square. Omega p is V by R, that also we saw it in the session. So V is given as 55.6. I have converted into meter per second, by R, because R is in meters, by 50. So you will get the value as 1.11 radians per second, and I is 36 multiplied by omega 251 multiplied by 1.11, and then the final answer is, so this particular, so this is your, and then it also is asking what is the effect of the gyroscope. So let me tell you the scenario. We are watching from the rear end, the plane turns left and the propeller is rotating, I think it's rotating clockwise direction. Yes, it is rotating clockwise direction. Okay, so it is viewed from the rear end. So you tell me what will happen, what will be the effect of the gyroscopic couple, to raise the nose or to dip the nose. So if we see in this particular scenario, if it is clockwise, if this is anti-clockwise, aeroplane takes left turn, it dips the nose and raises them. But if it is clockwise and it takes left turn, so it should raise the nose and dip the tail. So let's see, yeah, the answer is raise the nose and it will dip the tail. So with this, we finished the topic on effect of gyroscopic couple on an aeroplane. Thank you.